Hello everyone. Today we will be discussing on an interesting topic, which is nothing but the columns. So these columns are a very familiar constructional member that you all are familiar with. So in this session we will be discussing on the types of columns, the load carrying capacity of the column, the nature of failure of the columns, and we will look at different aspects of the column. So moving forward, what exactly do we mean by a column? Columns are mainly constructional members used to carry axial compressive loads. So their sole purpose is to carry the load. So in our previous session we learned about beams, and now we are discussing about columns. So what are the basic difference between these two? Because these are the two major critical components that is used in a building. When you look at the construction of a flat, you can see on a strong base they started to construct the columns, and columns are interconnected by beams. Like that they advance in their design. So what is the basic functionality of a column and a beam? Beam we have already learned that beams are designed to carry the bending. We know that when we enter a building, or when we place different things in a building, it is going to load the building. So these loads are located at different parts of the building, and thereby it creates different types of or different magnitude bendings. So beams are the one which carry these bendings. Now what about columns? Columns are the one which carry the load. So columns are designed to carry these loads. They are directly carrying the load. So in simple words, we can say that columns carry load and beams carry the effect of this load. So that's the easiest way of explaining about the column. So another structural member is called as a strut, but basically struts are placed in an inclined manner. Usually columns are not being used in an inclined manner. So columns are basically placed in a vertical position. That is the ideal position of a column, but struts are mainly used in an inclined manner. But we are not focusing on struts, we will be focusing only on the columns. The most familiar name that you might have heard about column is the pillars. That is the most commonly used name for the column, and that is too in the constructional sites. And what are the factors that affects the load carrying capacity of the column? Basically three factors. One is the cross section. It can have any cross section like circular cross section, square cross section, like that. So if you look at the first figure, we can see that this is a column which has a square, somewhat a square cross section. But if you look at the second figure, we can see the circular type of columns. And the third most important factor is the end conditions of the column. What do you mean by end condition? The name itself is the answer. End conditions. End condition means how the ends of a column are placed, whether they are fixed, whether they are hinged, or whether they are free. So if you look at this particular figure on our right hand side, we can see these columns. The first figure has got two different columns with the square cross section and circular cross section. But look at the geometry, look at the end condition. Both are fixed. Here it is fixed, here it is fixed. Similar here, the end conditions are fixed. It is not allowed to move in any direction. It is not. It is arresting the moments also. So those are fixed conditions. But when you look at the third figure, you can see a considerable difference in the end condition, where one end is fixed, the other end is free. There is nothing on the other end to restrict its motion. So like that, we have different type of end condition which will determine the load carrying capacity of a column. So we will discuss all those different end conditions in the coming sessions. And when we discuss about the failure of a column, what are the two different methodologies under which a column can fail? So basically two mode of failures are expected to happen in a column. The first one is called as a buckling, or otherwise it is called as crippling. The other name is the crippling. Crippling means if you apply a load like this, the beam is going to have a deflection like this. If you look at the practical example here, you can see upon the application of load, this particular column has deflected from the axial line. So such kind of failures, this is also considered as failure, one of the most important type of failure, which is not expected in a beam, but this failure is by buckling or called as the crippling. You can see a column is crippled. But what about crushing? Crushing is very easy to understand. If you take a piece of chalk and if you place in between your fingers and if you squeeze it, it will get crushed, got crushed. Similar manner, if you look at the second figure, you can see because of the load, the entire cross section has got crushed and failure has occurred. So these are the two major type of failure modes that we have to discuss, which will be discussed in the coming slides. Okay. Now moving forward, what are the types of columns? What are the basic types of columns? That's one of the important things we have to discuss. Basically, columns are divided into three categories. One is the short column, second one is the intermediate column, and finally we have the long column. So it's purely based upon the slenderness ratio that you are not familiar right now. We will discuss that later. But these short columns, intermediate and long columns are determined or categorized using the slenderness ratio. So kindly note down these values, which will help you to categorize the columns. Now, we have to understand why these columns are classified as short columns, intermediate columns, and long columns. It is purely based upon the mode of failure. So if you look at a short column, it's designed or it fails by crushing. Short column, as the name suggests, it's comparatively very small in size. So they usually fail by crushing. Long columns, if you take, they are comparatively long compared to that of their cross section. So they usually fail by buckling. And when we go for the intermediate columns, a combined effect of crushing as well as buckling can be noted in a column. So when the failure happens, that is another question. So this is the mode of failure, crushing, buckling, and the combined mode. Now the question is why it fails. Answer is very simple. Whenever we apply a load and the stress developed within the material crosses the ultimate value, it fails. Simplest answer that we can give. That's the reason. Short columns fail when the direct crushing beyond the ultimate value. Okay. Similarly, for long columns, when it goes beyond the buckling or crippling load, it fails. So combined effect, when the load crosses a particular combined value, then the intermediate column fails. So this is how we categorize the columns into three. And when we talk about the equilibrium of a column, there are mainly three types of equilibrium. One is the stable equilibrium, second is the neutral one, and finally the unstable equilibrium. So what is the meaning of this stable equilibrium? Answer is very simple. See, if the developed stress, I will say that it is sigma. If sigma is very much less compared to that of the ultimate load stress, the beam is in a very stable equilibrium. No effect or no possibility of a failure can be expected. But if you have sigma equal to sigma ultimate, that means the applied stress or the stress developed due to the applied load is equal to the ultimate load. Definitely, it is called as a neutral condition. Anything can happen beyond that. And finally, you have the unstable equilibrium where the applied stress is greater than the torsion stress or the ultimate stress. Or in other words, I can say that the applied load P is less than the ultimate load. Or here I can say that the ultimate applied load is equal to the ultimate load, and here the applied load is greater than the ultimate. Ultimate load in the sense means the load that can create an ultimate stress. That's the only meaning. Okay. There are some textbooks they have used that terminology. That's why I talked based upon the value of P. So basically, all failures are compared with the ultimate value or the yield value. So whenever the developed stress crosses the yield value or the ultimate value, we are considering it as a failed one. That is the most important conclusion you have to keep in your mind. So now let us discuss about the Eulers theory for the columns. From here, we are going to discuss about the long columns. We are not focusing on any other columns. Long columns, because long columns are expected to fail by buckling. So Euler has derived a set of equations to find out the buckling. What is the limiting load in buckling? So under what load the long columns are safe to operate. So that is the purpose of Euler's theory. So a certain assumption has been formulated by Euler's theory. Some are the columns are initially perfectly straight. No kind of deformation is there in the initial condition, and it is axially loaded. It's a very important term, axially loaded. Eccentrically loaded beams are there, but still for Euler's equations we are deriving only for the axially loaded one. Second one is the cross section is uniform throughout. You cannot have a variation in the cross section. And obviously the assumption that we use for most of the derivations is the elastic, homogeneous, isotropic and the Base-Hooke's law. It has to be there because we are dealing with something within the elastic limit. And length of the column is very large when compared with the lateral dimension. So if you compare the diameter or the width and the thickness, the length is very much high. The self weight is ignorable, and the column failed by buckling alone. We are not taking any kind of combinations. We assume that the complete failure of the column is directly due to buckling. So these are the assumptions which are very important, and these are the assumptions that we have to consider before we go into the Euler's derivation. And what is a sign convention that we have to use here? So there are different types of failure in columns. For example, if you take a n condition like this, and if you apply the load here, we can see the column bend buckle like this. Okay, so if we look from here, we can see a concave part. Such kind of bendings are called as the negative ones. And if you take another end condition like this, we can see it has buckle like this. So if we look from here, then we can see a convex part. Such kind of bendings are called as positive. So these are the two sign conventions that we have to keep in your mind before we move into the Euler's derivation. Now, what are the end conditions? I have explained in the previous slides about different end conditions which are usually applied in a beam. There are 4 different end conditions that we have to consider. What are those? One is hinged condition, both ends pinned. So you can see here and here it is pinned. When you apply the load, it can move like this. So there is no moment reaction here because it can rotate at this end condition. So they are called as pinned or hinged. So there will not be any kind of moment, reaction moments here at the subdivision. Second one is the one end fixed, other end free. If no fixed, other end pinned. You can see here one end is fixed here, but other end is hinged. Third one is both ends fixed. Here also it is fixed, here also it is fixed. Okay, that means here it is not hinged. You can see here it is rigidly fixed over here. And finally we have one end fixed, other end free. These are the 4 end conditions we have to discuss about. There are no other conditions other than these. These are the 4 commonly used end conditions in the case of a column. So we have to derive the Euler's equation for these 4 cases: hinged conditions, fixed free condition, fixed condition, and finally fixed free condition.